Alright, in this video we're going to continue our discussion of algebra review for calculus. And we'll focus on simplifying expressions. So let's jump to an example. If you want to simplify 2 over x squared minus 1 minus 1 over x minus 1, what would you do? Well, I'm trying to add the fraction, well, in this case I'm trying to subtract the fractions, right? So I need a common denominator, and I notice that x squared minus 1, so I look at the denominators. I see that they're not the same, right? And I need a common denominator. And so naturally, one thing you would look at is, can I multiply one of the denominators to get the other denominator? Now, if you can't, then one thing you can do is you can multiply the denominators by certain things to make the denominators match up. But in this case, I can multiply x minus 1 by what? X plus 1. Again, I have a difference of squares. So this is going to equal 2 over x squared minus 1 minus 1 over x minus 1. Well, I just wrote it again. But what I'm going to do is I'm going to multiply the top and bottom of the 1 over x minus 1 by x plus 1 over x plus 1. Now this way I'm not actually changing the expression, because when you're multiplying and dividing by something, you're just multiplying by 1. Okay? And now what we need to do is we need to figure out what this is. So I have a minus, and then on the bottom I'm going to have an x squared minus 1. And on the top, I'm going to have a 1 times x plus 1. That's just x plus 1. Now here, I'm ready to subtract the fractions because I have a common denominator. Right? Now I have a common denominator. And so I just combine them into one fraction with the same denominator. And I have a 2 minus. Now, again, you need to have parentheses around the x plus 1. So it needs to be parentheses x plus 1 because you're subtracting the quantity x plus 1. And this is going to be 2 minus x minus 1 on the top over x squared minus 1. And now we're ready to just combine like terms. So I have a 2 minus 1 on the top. That is equal to 1. And so I have a 1 minus x. Let's write that as negative x plus 1 over x squared minus 1. Okay, now at this point, can we simplify this a bit more? Well, it turns out the answer is yes, because first of all, I have a difference of squares on the bottom. So I can write this as negative x plus 1 all over x plus 1 times x minus 1. Now here's a little trick. So I have this negative x plus 1 on the top. That's the opposite of x minus 1 here on the bottom. I have this here and this here. In other words, if I factor the negative 1 on the top, then I'll be left with x minus 1. And the bottom stays the same. And then these x minus 1's cancel, and so I'm left with negative 1 over x plus 1. So that's the simplest form it can be. All right, I guess we could have saved time if we had left um, the bottom factored instead of combining it and then unfactoring again. But anyway, so let's look at an example. Okay, you could have an example of a problem where this kind of simplification shows up. Usually it's involving limits. Well, let's take the limit of this as x goes to 1. Okay, this is a little too easy because we already did the problem. But you might have something like the limit as x goes to 1 of 2 over x squared minus 1, and then, sorry, let me scroll back, minus 1 over x minus 1. So this is a typical example of a problem that you might see in a typical calculus class of a limit. Now the first inclination is to plug in the 1. And if you plug in the 1 into this function, you get, well, 2 over 0 minus 1 over 0. That's undefined. Basically what happens is that this first expression is approaching either infinity or minus infinity, and then this expression is approaching infinity or minus infinity. And if you think about it, what's happening is when x is approaching 1, let me think. What you're going to get is going to be, let's see, I mean, what you have to do is you have to analyze what happens when x goes to 1 from the right or from the left. Because what happens is, as x goes to 1 from the right, okay, you get this is slightly positive. I mean, this is approaching 0, but it's positive, and this is approaching 0, and it's positive. And so when you do 2 over that, you get positive, and you get 1 over that's positive. So you have this indeterminate form, infinity minus infinity. And if you're approaching 1 from the left, then what's happening is that x squared minus 1, so when x is slightly less than 1, x squared is less than 1, right? And so when you subtract 1, you're getting a negative number. And so this is going to be less than 0, and so this quotient is going to approach minus infinity. And if you have this x minus 1, since x is slightly less than 1, this is also negative. And when you have 1 over a negative number, that's negative, and so you have minus, you have something that's approaching minus infinity, and so you get this minus infinity plus infinity indeterminate form, right? So these are indeterminate forms. If you had infinity plus infinity, then the limit would be infinity. If you had minus infinity, then the limit would be minus infinity. But here you have you have infinity minus infinity, that is an indeterminate form. So you really do need to do some algebra to work with this, and we simplified this. So let me probably do it let me just do it out. So this limit is equal to the limit as x goes to 1 of 2 over x plus plus 1 times x minus 1 minus 1 over x minus 1. So I'm doing this, I'm factoring it because I know that in hindsight it's better to have it factored, right? Because, you know, we're doing a limit and we're trying to make things cancel. So now we see that I have to multiply the right hand side by x plus 1. And this is equal to the limit as x goes to 1 of 2 over x plus 1 times x minus 1 minus x plus 1 over x plus 1 times x minus 1. And then this simplifies to the limit as x over 1 of 2 minus x minus 1, so that's negative x minus 1. Is this matching what I had before? Did I make an algebra mistake? Let's see. Oh, did I write the wrong thing? Oh, oops. Okay, let's double check the algebra. Oh no, this is right, this is right. Okay, so I have this, and then I have x plus 1 times x minus 1, right? And now I can factor out the minus 1 from the top. So I have minus 1 times x plus 1 of x plus 1 times x minus 1. What is going on here? This isn't right. Okay, of course. Because I have a 2 minus x minus 1, but I have the 2 there, right? And I have a 2 minus 1. So it's going to be a negative x plus 1. There we go. There we go. And then we factor out the minus 1, and we have negative parentheses x minus 1. And now the x minus 1's cancel because I have a factor of x minus 1 and a factor of x minus 1 on the top and bottom. So I get the limit as x goes to 1 of negative 1 over x plus 1. Now I can substitute and I get negative 1 over 2. So that is an example. Let me see if I can zoom out. This is an example of a typical calculus problem involving limits. So this is something that might show up on the first midterm. If this is a semester course with 2 midterms and a final, then this kind of question usually shows that if it shows up at all, it will show up on the first midterm, which is about limits, and then it might show up on the final. Okay, let's do another example of simplifying, and then I'll do an example of where it shows up. So, okay, here's an example. How would you simplify cosine x over sine x, and then this whole thing over negative x to the minus 2? Well, okay, so spend a minute on this and then let's check if we get the same thing. All right, let's go over the answer. So this is something where I have something divided by something else, right? I have cosine x over sine x, and then this whole thing is divided by x to the minus 2. So when I have something to a negative exponent, it's helpful to think of it as 1 over x to the positive exponent, because x to the minus 2 is equal, by definition, to 1 over x squared. Right? So this is equal to cosine x over sine x, that whole thing divided by negative 1 over x squared. You don't need the parentheses here. But negative 1 over x squared. I think it's a good idea to just have the parentheses just to illustrate what's going on. So now I have a fraction divided by a fraction. And when you divide by a fraction, you multiply by the reciprocal, right? But that essentially is a consequence of the way multiplication of fractions works. So this is equal to cosine. Now I have a minus sign. Okay. So I can move the minus sign out front because this is a negative 1, right? I can think of this as negative 1 times 1 over x squared. Right? I can think of this as 1 over negative 1 times cosine x over sine x all over 1 over x squared. And 1 over negative 1 is negative 1. So I have a negative in front. So I have a negative cosine x over sine x. And when I divide by 1 over x squared, that's the same as multiplying by x squared over 1. So this simplifies to negative x squared cosine x over sine x. And this is the kind of thing that you want to make sure that you can do before you take calculus. Now let's do an example of where this calculation shows up. So let's find the limit as x goes to 0 from the right of sine x raised to the x power. Okay, so this is a limit, and I see that I have something involving x, right? The sine x involves x, raised to something that involves x. And when you do that, generally what you want to do is you want to take the natural log of that. So we'll take the natural log of sine x to the x. Maybe before we do that, I just want to explain how why we do that. Okay, so this is equal to the limit as x goes to 0 from the right of e to the natural log of sine x to the x power, like that. Because natural log and exponentiation undo each other, and then this is equal to, since exponentiation is a continuous function, this is equal to e to the limit as x goes to 0 from the right of the natural log of sine x raised to the x power. That's what's going on. And so that's why to evaluate this limit that we want, you can evaluate this limit. We want to evaluate this limit. So we have the limit of sine x raised to the x power, right? And in fact, we don't even need these parentheses. When you have something like this, it means sine x to the x power, and then you take the natural log. So this is equal to what? We use our exponent facts, right? This is equal to x times the natural log of sine x. Because again, we're using the algebra fact that when you have natural log of a to the b power, if a and b are positive, this is equal to b times the natural log of a. And here our a is sine x and our b is x. And when you just apply this fact, you get what we get. So we need to figure out the limit as x goes to 0 from the right of this thing, x times the natural log of sine x. Now when I plug in x equals 0, I'm going to get 0 here. So I have this product, x times ln of sine x. If I plug in x equals 0, I get 0 here. Right? What do I get here? Well, I have sine of 0 is 0, ln of 0, well, that's undefined, right? Because when x is going to 0, this is approaching negative infinity as x goes to 0. And so I have an indeterminate form. 0 times infinity or 0 times negative infinity, that's an indeterminate form. And when you have something like that, we need to do algebra, but in this case we need to use L'Hopital's rule. And the trick is we want to get it in the form 0 over 0 or infinity over infinity to use L'Hopital's rule. Okay, so the algebra is to rewrite this as natural log of sine x all over 1 over x. And these are the same because when you divide by a fraction, you multiply by the reciprocal. But now what happens, see, why do we do this? It's because now what kind of expression do you have? When you plug in 0, you get, infinity here. And on the top, you get, well, it's actually minus infinity on the top. Right? And of course, when you're plugging in 0, we're really taking the limit. Okay. And getting that the limit is minus infinity on the top and the limit on the bottom is infinity. And now we have something where we can apply L'Hopital's rule. So by L'Hopital's rule, and I'll put, what I usually do is do this. So now I have the limit as x goes to 0 from the right of, and now I need the derivative of the top and the derivative of the bottom. So the derivative of the top is cosine x over sine x, right, by the chain rule. I have 1 over sine x and I have to multiply by cosine x, and then on the bottom I have negative 1 over x squared. So I have this divided by that. And that's where this example shows up. Here. Right? And so this is equal to the limit as x goes to 0 from the right of negative x squared times cosine x over sine x. And now we get, now what happens when you plug it in? On the top you get 0 because I have this x squared that's giving me the 0, and on the bottom I have sine of 0 is 0. So I have 0 of 0, so now I need to do L'Hopital's rule again. So this is equal to, by L'Hopital's rule, the limit as x goes to 0 from the right of, okay, now I have a product on the top. So the bottom's easy, right? I just have cosine x. And on the top I need to use the product rule. So I have, let's just use the product with, I mean there's multiple ways of doing it, but let's just use the product rule with, how do I want to do this? Okay, I'll use the product rule with negative x squared and cosine x. Usually what I do is I'll just factor the negative 1. Actually, you know what, I think it's better to factor out the negative 1. You can always pull out a constant from the limit. Right? So I have negative 1. Let me just get some space. I have a minus, then, oops, what am I doing? This is equal to, by L'Hopital's rule, negative the limit of x squared. Well, okay, so I have to take the derivative. So I have x squared times negative sine x, and then plus 2x times cosine x. Right? That's the product rule. And now I can evaluate the limit, finally, because I have 1 on the bottom. So this is equal to negative, and then I have a 1 on the bottom. On the top, when I plug in 0, I get 0 here, right? And here I get 0. So I do get 0. And negative 0 over 1 is 0. And so finally, we can evaluate the original limit we wanted, because we found that this limit in the blue is this limit here is equal to 0. So now we get e to the 0 power, and that's equal to 1. So the answer is 1. Okay. And this is fairly typical of the type of algebra that you see. So this is a L'Hopital's rule limit. And as you notice, the algebra shows up in the step, right? So if you didn't know how to get from here to here, you would be in trouble. Yeah, you wouldn't be able to do this problem. So and it's embedded in a problem, right? This is like one question. It's the algebra is one step, right? So and you also need to use some natural log facts, right, to get from here to here. You need to use a property of natural log. So this is a typical L'Hopital's rule question, and you need algebra to be able to solve it. Yeah. Okay, so today we did some, what did we do? No, we started here. We started rationalizing, we talked about simplifying expressions, and we showed how that's useful in solving limit problems, right? Combining the fractions. The combining the fractions also shows up when you're evaluating derivatives using the limit definition. And we talked about when you have a quotient of two fractions, right, you can multiply by the reciprocal, and that will simplify things, and then we use that to solve a problem using L'Hopital's rule. Okay, thanks.